Hi everyone, my name is Megan. I'm with Los Alamos National Lab, and for the next 20-ish minutes, I'll be talking about wrangling the Charliecloud modules, specifically with updates in release 0.40 and newer. So I'll do a little introduction, go into CDI and why container device interface broke all of my modules, and then what I did to change it. And I'm pretty sure I'll have time I can do a demo and show kind of how quick I now have it set up, so I can just quickly add a new module. So I just want to clarify kind of the scope of the modules I work on. So I only do the Charliecloud modules on Lano's testbed cluster, which is Darwin, not the production clusters. That's a whole different beast. I do not touch those. This is just the testbed cluster. So previously, before CDI changed some things, I just had one script, or I guess 3 scripts, that built Charliecloud on the 3 different architectures of the different compute nodes, and then each had its own module file. So 3 modules, 3 module files, 1 per architecture. CDI broke it, and I didn't realize it, so a user reported it, then I was deep diving into fixing this for me. So just for a kind of quick summary, NVIDIA CDI, pretty cool new feature. It allows users to no longer need to run ch from host -- NVIDIA in order to utilize NVIDIA's container libraries. So now instead of a ch from host, users can just add a -d flag and ch run. So what's needed for all of the NVIDIA GPUs is a CDI.json file. It's pretty easy to create. You just have to run NVIDIA CTK CDI generate. Creates this, saves. I won't go into the weeds of what's all in here, but it isn't horrible to read if you did care about the nitty-gritty details. Okay, so now new module management challenges. So for each of the different GPUs, it needed a different CDI.json file. Then CPU nodes wouldn't ignore the CDI.json file. So if there was an extra file with a CPU node, things crashed, users angry, not a good time. So this is also a testbed cluster, so it is constantly being changed with new nodes added. And I also only had like a couple of minutes every time there's a new release to quickly add it before I forget or get distracted. Yeah, so with the testbed cluster, there's a whole bunch of nodes, whole different architectures, whole bunch of different GPUs, nodes change. Yeah. Okay. So the module structure, which is predetermined by the actual sysadmins, is that there is one install for each architecture. But what makes this really challenging was the fact that there was a whole bunch of nodes, a variety of them with the same architecture. So kind of the goal of this new change is when the user loads the Charliecloud module, want to make sure that it works for CPU and GPU nodes, because users don't want to have separate modules for both. They would get angry. I also want to make sure that it links the correct CDI.json file. And what is the process that will make my life easier? I wanted to spend a couple or some more time up front so I wouldn't be banging my head against the wall in the future. Because this is always like the Charliecloud releases, it's always when I'm in the middle of doing 18 million things, so I'm just trying to like quickly do it in between phone calls. So what ended up working the best was I actually had to tweak the actual module file for Charliecloud versus the install. And it's a little funky and weird, but it's working so far. So this is kind of high level, the new logic I had to add. So in the module file, it first checks if the node is a GPU. Then it checks if it is a NVIDIA GPU. And if it is, it will do all the CDI stuff. But if it's not a GPU or not an NVIDIA GPU, does nothing, kind of works as it originally did. So in the module file, how I checked that it is a GPU, I ran NVIDIA SMI, and there's kind of 3 kind of main categories of output. We have our good old error message, NVIDIA SMI has failed. NVIDIA node, and then a non-NVIDIA GPU. So the first error message, if we get that, we know that it's the CPU, so we don't do anything. And then every other output is a GPU, so we're happy with that. So it just kind of checks if the string starts with NVIDIA SMI, then it fails. Doesn't do any CDI stuff. To confirm that it's an NVIDIA GPU, not a different type of GPU, you just check the first part of the string. So the NVIDIA one starts with NVIDIA, yep, but the Tesla GPU is no. So from there we do the CDI stuff, which is every time the module is loaded, it creates its own CDI.json file. Decided to do that just so if new nodes get added, I don't have to do anything. Also, there isn't really any performance impact, and that just made things a bit simpler. And then once the CDI.json file is created, I just set that CDI.json location to the variable chrun CDI ders. So this is kind of the full code that's actually, or I guess, not really code. This is what's actually written in all the module files. So this is the full kind of line that checks if it is a GPU, and then if it starts with NVIDIA, and if so, creates a CDI.json file. Yeah. So impact, less work for me, which is always the goal. Yeah, so it hasn't broke yet. Users haven't told me things are broken, so things are very looking good. The one kind of con is that the CDI.json file does have to be created for each time a user reloads the Charliecloud module, but there's not really performance impact because it's pretty quick. Other pros users don't have to do anything on their end because users just want to be able to do a module load Charliecloud and it works for them. So so now I'm going to hop on Darwin, the testbed cluster. I just went through and deleted one of the older releases so I can show kind of how quick it is. Okay. Oh, cool. Yeah, so this is kind of, sweet. So I do this not very consistently, so that means I never remember what I'm supposed to do. So I have everything stored in a single directory. Even gone so far to make me my own README, so I know exactly what I have to run. So just in this directory, I have my README text, which reminds me what partition I need to go to do the different installs. And then I have one script per each different architecture. The names don't really make sense. They're based off of what I remember. And then I have a module file script, which automatically creates a new module file for each install. So I'll start with the README one because I don't remember the order. Yeah, so these are all the commands I do to update all the different modules. So you can see here when I build the scaling one, I can do that right in the front end node. And then I have to go to the ARM node to do ch ARM and so on and so forth. But the scripts are pretty straightforward. They also have some tests, just because there's a couple of finicky things that have been gotchas and it's broken and I haven't realized it. So I just added some quick little tests. So you can look at so each script is kind of formatted the same. The main difference is where the build path is, because it's different depending on the architecture, and in squash views. But when I took over during the Charliecloud modules on the system, someone already installed squash views, so I just keep using that path because I don't want to reinstall it. The first thing it does, it checks that I actually included a version number, because that's just required. Then it goes into the build location, CDs into kind of our main source directory, fetch, and checks out the most recent release. Then go over to the build path, and then we copy over the main. So now we have a whole new directory that has the most recent release, and then we build it. Autogen configure. This just has all of the different kind of libraries saved in different places depending on the architecture. And then from there, we just do a quick little test. So I just make sure I'm able to load the Charliecloud module, able to pull and convert between a Charliecloud storage directory version and a squashfs, because the squashfs library has gotten finagled in the past. So this is like the quickest check just to make sure nothing got botched there. Also make sure nothing's funky with Python, so just kind of write this test right here. Just shows that, yep, it's able to run a container. Straightforward. And this one, what's this? Oh, this makes sure that the container, or that Charliecloud is able to run with the squashfs. I'll just kind of, so I just deleted an old version, so hopefully this just works. My own scaling. Yeah, so this is its building. I will say it's normally even quicker when I'm not on conference Wi-Fi, connected to LAN and VPN. Currently it's building. Checking. Yeah. I always know the build seems to be right as soon as I get to yellow text, 'cause that's where I know the test output changes. And I just make sure, okay, this container ran foo, this one ran foo, we're good. And then I can move on to the next one, which is yeah, so now I'll do it for ARM. It's the same exact thing, just different paths. But I have to just go to that node. And we'll see if I can actually get onto a node. Oh, sweet. Currently, all of our other open HPC clusters are down for maintenance besides this one, so it's been a little spooky trying to make sure that I have access to what I need. But just take a quick look, we can see chmod ARM. The exact same thing, just different paths. And I include the path to the CJSON. Yeah, configures the same tests, just different paths. I was gonna make it smarter so I wouldn't have to have 3 separate scripts depending on the architecture, but I never got around to it, so that's why it's all separate. But it's also fast. Yeah, 0.0. Yeah, so you can see it's doing get stuff, and now it's configuring. Yeah, I have it for a third architecture, but I didn't want to. There's only a handful of nodes with the final architecture, because it's with the Grace and Grace Opera nodes, and I didn't want to take that from a user. But once I have this built, I just quickly add the module file with my module file script, and things seem to be working. If I do break a module, I get an email usually pretty quick, which is glad, because I know people are actually using Charliecloud. So we have foo and foo. We're happy, we're good. Now let's do the module files. So the module files is just straightforward. I just don't remember the paths ever. So I just make sure I have all the paths saved for where all the module files need to go. And I just keep kind of like a dummy empty module file in each of those locations so that I can just copy and name to the new version release. And then I have it set up so far as to make sure I actually go into Vim and edit it. I also include updating the default version because we want the default version in most cases to be the most recent release, unless there's a known bug that we find out after the fact. Yeah, so I'll just do that and ignore the Grace ones. Yeah, so this is what the module file looks like. So we have all this stuff from the talk before. And I just update next the release. I don't want to change the default. Then for here, we do want to add 0.40. So keep the same. This is for rel 9. I'll have to test after the fact to make sure I didn't break this. And that's it. And just kind of always just do one last sanity test to make sure that it's actually there. Yeah, so we have 0.41. We're good, we're done, and that's it. Yeah, so it's not very interesting from a user perspective or even a sysadmin, but I kind of just want to show how once it was set up, it was pretty straightforward. Ooh, and I'm out of time. I don't know if anyone has any questions. Otherwise, we can go to the next talk.
I have a question.
Yeah.
What language was it that you showed that had the really weird syntax right at the beginning?
The module file ones?
Yeah.
I don't remember. They're two different ones. One of them is a Lua file, and one of them is something else. Let me look. You can tell how often I do it when I can't even remember what language it is. This is just mod.
Yeah, that language.
I'm gonna be honest, I don't remember. Okay. This was just pre-set up, and this is what it has to use. One of them's Lua file, one of them was something different. Because if we go to, whoa.
Is that not the Bash?
That's not Bash, no?
GCL.
Yes, that was the other one.
Yeah.
Thank you. Yeah, because we arm. Yeah, if you can't tell, I learned real quickly that I needed to really hard code this because there's no way I could remember this just because I do it only a couple times a year. I think arm's the Lua. Or I guess they're both tickle. I don't know. Anything else? Sweet. Then we can go on to the next talk.